So today, when continuing from yesterday, we are going to solve stack stack problem. Yesterday we solved linked list problem. A few of the linked list problem like copy list with random pointer, add to pointer, find duplicate, and then reverse node in a key group. Okay. So today we are going to we have left this problem because it is a design problem. We are going to solve all the design problems later, so that's why I'm not solving the design problems right now. So today we are going to solve a stack problem because uh, uh, before that I was thinking of solving the binary tree but binary search problem, but I thought let's start with the stack problem, then we'll move on to the binary search. Okay, so let's start with the stack problem. So today we are going to solve the minimum stack. Okay, so let's read through the let's go through the question and try to understand what's the problem. Okay, so it's also a design problem. Okay, so leave the design problem. We will not solve the design problems right now. Okay, so let's move on to the next problem. Okay, let's see which is also today. Okay, so we'll try to solve this problem. So let's read through the problem and try to understand what the question is asking and how to solve it. Okay. So evaluate a Polish notation. Reverse Polish notation. You are given a string tokens that represent an arithmetic expression in a reverse Polish notation. Okay. Evaluate the expression and return the integer that represents the value of an expression. So know that the valid operators are plus, minus, and this. Okay. Each operand may be an integer or another expression. Okay. The division between two integers always truncate towards 0. Division between two integers always truncate towards 0. There will not be any division by 0. Okay. So the input represents a valid arithmetic expression in a reverse Polish notation. Then the answer of all the intermediate calculation can be represented in 32-bit integer. Okay. So what's the reverse Polish notation? So like 3 plus 4. Okay. So 3 4 plus, that is 3 plus 4. Okay. 3 minus 4 plus 5 becomes 3 into 4 minus 5 plus. So 3 minus 4 plus 5. So let's try to we have given it as a string, vectors of string, and we need to first get this one. Then after getting this one, you need to get the result and then return that result. Okay. So how can we solve this? Okay. So let's go through the example. Like we have given 2 1 plus 3 into 9, then 4 13 5 division and plus. Okay. Then a long one. Okay. So if 9 plus 3, then we have multiple, that will be minus 9 minus 11 plus whatever the result of 9 plus 3 is. Then we have division. For division, whatever the result of 9 plus 3 minus 11 divided by 6 divided by that. 6 divided by that. Okay. Then we have multiple. Then okay, all of this multiple 10. So simply what we can do is like we can keep adding element to the stack, like let's try to go through the problem. Okay, 20. Let's try. Let's try to go through the problem. Okay, so we will create a stack. Okay, first we'll add the first element 10, add another element 9, so 6, then another element 9, then another element 3, then plus. Once we get an operator, okay, once we get an operator, what we will do is pop 2 of the element from the stack, right? And using the operator calculate whatever the 2 elements provide. Okay, so basically once we get an operator, what we'll do is pop this and this, that will be 3 plus, sorry, no, sorry, 9 plus 3. Okay, down first, then second one. Okay, then we'll get this one, then we'll pop these both. Okay, so pop this. Now we have 9 plus 3, then we keep on moving, then we'll add minus 11, then we move on to multiple. So once we have another operator, what we will do is pop 2 of the element, no, sorry, after, what we'll do is after getting an operator, getting an operation, this, whatever this operation is, and getting its result and adding that to a stack. Okay, so 9 plus 3, that will be 12. So what we will do is we'll add 12 to the stack before moving on. Okay, so now we have 12 in the stack. Now we keep going up. Okay, so now we'll add minus 11, then we have another operator. So once again, if we get an operator, what we do is pop 2 elements, 12 into minus 11. Okay, simply what way, and this 12 is from 9, so let's start later. So 9 plus 3, then we'll have 12 into minus 11. Okay, now we have this, we'll pop these 2 element again from the stack and get the result of this one. So this will be 12, 120, 131. So minus 131. So minus 131. Sorry, 132. Minus 132. So again, we keep on moving. Then what we have? Division operator. Again, we get a division operator. We pop last 2 elements from the stack. So let's what we do is pop the last 2 elements. So 6 divided by minus 132. Okay, now we have 6 divided by minus 132. This 6 divided by 132. So this will be 11. We have below first, so if we get 9 plus 3, we add that, then we add minus 11. Okay, well, that's fine. So this is fine. We'll add minus 32 plus 6, the 6 divided by minus 132. Well, this is a problem. We have 9 plus 3, then whatever the result is, multiply by this, and then 6 divided by minus 132. That is 6 divided by minus 132. And we pop two of these elements from the stack. Now we are on division. Okay, and whatever the result of this will be, we'll be adding it to the stack. So calculator, let's get the result. 6 divided by, how can we do this? Can we get 6 divided by minus 132? So this will not work. One second. 6 divided by minus 132. So we'll get 0, because we will get 0 minus 0.4545 and so on. So we will just add 0 because our overall integer, we need answer as integer, so we'll have 0. Then for this, then we'll add multiply. So again, we have an operator. We'll pop two of the element from the stack. So what we'll get is simply time into 0. That will be, so we'll pop the both of from the stack, add the result of this to the stack, that will be 0. Okay. So we'll add the result of the stack, that will be 0, and again we keep on moving, then we'll get 17. So 17. Okay, then again we have plus. So what we'll do is pop both, that will be 0 plus 17, that will be, then again after getting the result we pop both of those, add the result to the stack, that will be again 17. After getting the result, that's result, then again we keep on moving. 17, we have plus. We have plus here. Okay, sorry. First we have 9 plus 3, then result will be 12, then 12 into 11, that's fine. Then here we have 6 divided by whatever the result of these are, so this is also fine. Then we have division, then we did division, then we multiply. So whatever the result of these are into 10, so we have this. Okay, so we have 0. So what we first said, we messed up here, I think. So after getting 10 into 0, whatever the result of this will be, we added here. So we are currently here, then we add 17, then we have plus. Okay, then we have plus. Okay, so we have 0 plus 17, then we pop both of these, we'll have answer as 17. Okay, so we have completed this plus, then we'll add 5, then again we have an operator. So what we do is simply pop both the elements from the stack. Okay, and that will be 17 plus 5, that is 22, so we'll add 22 as a result. Okay, at the end, whatever the top of stack is result. Okay, So let's see if 22 is the answer. Okay, so 22 is the answer. Okay, so let's try to implement this. Okay. So let's start a clock. Let's try to implement this one. Let's create a stack of stack of strings. Stack of strings. That's okay. So now what it is for each string, so for each character, C in tokens. What we'll do is first we'll check if the C equals to either plus minus, what are the options, plus minus, multiple and division. So if we have any of these, we will perform a different action. So division. Okay, we see if it is any of these, we will perform a different action. Else what we'll do is add stacked up push what C. Okay, simply push element to the stack. Now let's, if we have a C as plus or minus, does not matter. All we are going to do is simply create another function. I will call that function with the operator. Do that. If we create a function, we have to create 4 functions. Otherwise, we have to write here. Okay, so simply let's do this. And it's just int I1, so integer 1 will be, so integer 2 will be first pop. Okay, stack that pop, and int I1 will be s dot again pop. So we have now integer 1 and 2. So what we'll do, simply do is we'll have an simply we'll have an error and int result that will be is I1 plus I2. Okay, let's convert all of those to int. Okay, so int convert those into ints. Okay, now we'll have a result as this. Okay, so we'll have these as a result. Simply we'll pop the both these, and then after getting the result we need to push. Okay, push the result. After pushing the result, we need to what is the stack top element, we get C. We do not need to push C. We do not need to push the operator into the stack. Okay, so we simply do is continue. So let's copy this, paste it, all of it. Okay, so simply let's paste this here, paste it here, let's paste it here. Okay, so for this I am And for this we'll do I into I2, and for this I will do I minus I2. That's it. Divided by I2. Whatever we get, we'll have as an int. Okay, convert it into an int. So now we'll continue. And at the end, of the for loop, I will return stack dot top. Okay. So let's see if this works. So we have an error. For its char C in total. So we don't have char, we have list of string. So this will be strings. Okay. Let's see again. Let's try to. So now how to convert whatever the string into. So now we have a string. So this will be string, this will be string. So how to see how string into sorry. So how we do it? It's using a function. Okay, using a function stoy. So what it is, we include SS string. Using SS string to string SS string the num. We point it to this. So our first way is to use a stoy. Second way to use string, and third way is to use add toy function. Okay, so we have 4 options and 4 char. So let's start with the first option. Let's see with a stoy. Okay, so let's see if it does stoy. So this is how it is. Okay, now let's set it. Let's type. Let's paste it. Let's copy all of this. Paste it. Paste it. Paste it again. So let's minus multiple and division again. Let's do it. Let's see if it's works. This time also. So again we have an no matching function as toy. So it's inside the hashtag include. Okay, string. So let's include that. Include. Let's see, include string. Okay. Let's save. Now using am space std save source. Again, no toy, no toy function. So toy function is not working for. So let's add another. Let's try using string. Okay, so strings string. Okay, strem. Okay, so strem stream. What we do is simply stream, name it something like this, then we create a variable and assign it to that. So it's string string. Is that correct? String. Let's do s1 s dot pop. Okay, then all we need to do is s1 to write. So sorry, no. Let's see if this works. So hashtag include string. So ss string ss string. Is that right? S-S-S-S-T-R-E-A-M string. So let's see. Like in S-S-S-T-R-E-E-A-M. Copy this. Copy this. Paste it here. Let's copy these. Paste it here. That's it out. So S dot pop. So do maximum constructor for this string. So string. So what's the error? This one string pop. So straight away string is still string. Testing out one. Let's get the rest of then passing str1 this. So now let's see string s dot pop. So instead of pop, let's do top. Good. So now this is working. So all you need to do is instead of the pop, because I think I thought by writing s dot pop will pop, and whatever will pop will get it as a return. So let's STS stack in C++ FUH functions and so let's see. So pop does not return, so it has no return value. So that was the issue. So what do we need to do is top simply. So if we do this like this now, okay. So let's remove this. Let's just do this. Let's destroy that top. We do not need to do this. Okay, we do not need to do this. Maybe. Okay, so we do not need to do this. So it's fine. So instead of s dot pop, we do s dot top, and then before adding that element, what we do s dot pop, s dot pop, we pop twice, then we do this, and we convert this to string. Okay. So what integer to string. Okay. C++ 2 underscore string. Okay. underscore string 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 member reference fish int is not a structure or union. Plus, so simply we could do this. So toString function is not working. toString 2 underscore string. So we need to do this toString and write result inside of it. Okay, so now it's fine. Okay, so now let's keep on replacing these. Okay, we can create a function pass in after calculating both of these. You can pass in there. We don't write these all the times. If like we can do that. If we first change it, if it's not alphanumeric way, we can do that those things, but we can do it in simple way. It is easy to read and understand, but we are repeating multiple times, but it's still easy to read. So let's into division. So top step top string. So matching function to call toString. So we're already doing this here. It's already string. So toString up. So keep on string. I need to return, but the string I need to return integer. Okay. Let's see if this works. So it did work for the first case, did not work for the second case, neither did it work for the third case. Okay. So while we go here, pop these two, it 1000 divided by 5, that will be 2. 2 is added. 2 is added to this one string. Situation. We have plus, again, pop both of these. That will be 2 plus 4, that will be 6. This work. This and this. So from here, take both of those, get result, put it back. So this is its one. This plus this, this, we add this, plus this. What's the issue here? moving that we should have 22. What's the issue? We have two plus three, so that's 2 plus 3, that will be 2 plus 3, if it is 5, 5, then 13, that will be 13. We can put these on the top. We can keep on repeating the top. That will not affect that much of problem. That will not affect that much of a problem. Five divided by 30. That is 0 plus 0 plus 4. So why are we getting 2? Why are we getting 5? So where do we have okay both of these? We just can do this. These okay. Now if we are trying to convert plus 2 these and that, now that's an issue. Okay, that convert plus 2 this. Why are we getting error? Like I think at the end all we need to have is result. Let's go through them. All the elements in the stack at the end. Okay, for each string plus yes. I so invalid expression string with stack. So how can we traverse? If it is not empty, we keep on putting the top and bottom. So we can do this. Well, stack is not empty. All we need to do is press that top and then stop. Okay. Why? 39. I think that's right. If stack is not empty, what do I give the top limit value of that? When the stack will be empty. So why am I getting this? So what's the issue? Let's copy this. It's executive. Put it here. See if where do we have a plan. When the critical power is now you read operand from the stack. We are calling top twice without popping. Okay. Sorry. Okay, so what we need to do is get the stack event top, pop it, then get another element and then again pop it. Okay, so that's the issue. So what we need to do is, so that's it. Because we are doing top twice and without popping both the time we are getting the same top. So now it should work. Okay, so now we have what we want. So we are now let's go to the solution provided. But this one, if we use that, we're doing auxiliary reverse polish. So let's go through the solution.
Hey everyone, welcome back, and let's write some more NeetCode today. So today
we are using the stack and we are using it properly. So what's the issue?
Hey everyone, welcome back, and let's write some more NeetCode today. So today let's solve the problem.
So basically we had a minor. So simply we had a minor issue. Like once we get the top, we pop that top, then we get another top, then we pop the top. So instead of doing that, we were not doing that. That was an issue. So it's now working.
Evaluate reverse Polish notation. Quite a mouthful, but basically this problem is about what the meaning of that term even means, and it's just kind of a way to compute arithmetic expressions, and the only operations we're really going to be doing in this case are going to be the simple ones: add, subtract, multiply, and divide. One note that they tell us, though, is division between two integers should basically round towards 0. Since I'm going to be doing this in Python, though, if you take some values and do integer division between them, they always round down, which is not rounding towards 0 necessarily, because imagine if we had -3 divided by 2, that's -1.5. It rounds down to -2 in Python, but that's not what we want to do. But there's a trick in Python that you can do to make it round towards 0, so we can take care of that. If you're using Java, though, I think it automatically rounds towards 0, same with like C++ and most languages. One thing we're told though, in terms of the RPN expression, is that it's always going to be valid.
Plus, we are calculating from plus, we are minus, we are calculating from minus, if we are multiple, we are calculating it from multiple, and if we divide, we are calculating it for divide. Okay, so it's like understandable. We can do this like first loop. If any of this, if C is any of the operator, we get these two. After getting these two, again we see what operator it is. For that operator, we calculate the result, and for again that operator, after getting the result, we will push that into that. So we can do that. So we can do this like this also, but it's like this also works. So no need to do this also. So let's.
Which is good, so we don't really have to worry about too many edge cases. There's never going to be some divide by zero or anything crazy like that. So now what does RPN even mean? Well, let's take a look at this example. So we're given a 2, a 1, then a plus operator, then a 3, and then a multiply operator. Now the way this is going to work is we're going to be reading from left to right. We're going to be reading the inputs. So first one was a 2. Next one is a 1. When we reach an operator, though, what exactly are we supposed to do? Well, any operator in this case is going to be applied to the previous two values. And like I said, there's not going to be edge cases, so we're guaranteed that there are going to be two previous values. So in this case, what we would do is replace these.
So we have computed all of this. So these are my solutions. So this is my solution. This is my solution. I copied it from ChatGPT. So what we'll do is in the summation we'll write it. ChatGPT. Simplified. Okay. Let's write ChatGPT simplified. Okay. So otherwise this is also the same problem, exactly same, but instead of doing it in there, we first we are doing it differently, just little bit differently, like first checking if it is any operator using OR, then we do this, then we calculate the result, then we push the result, then we do this. In this problem what we are doing is continuing and keep on checking and doing continue. Okay, so if I wanted to simplify, I could have simplified it, but we don't have, like, we are just trying to solve the problem instead of simplifying it. So let's move on. Okay,
this 2 and this 1 by adding them together. So it's going to be replaced with a 3, right? So we can kind of forget these, and we already used this plus operator, so we can kind of cross it out as well. Now we have a 3 again, so I'm going to be kind of writing it down here just to kind of, basically say that we've seen that 3 before. Now we have the multiply operator that is going to be applied to the two previous values. Now in the actual input itself, you can see that the previous value was a 3 and the value before that was a plus operator. When we say it's going to be applied to the two previous values, that's not what we mean. We don't want to apply it to another operator, right? We mean the two previous values that came. So you can see that we had a 3 and then the one before that was a 1. But remember, this 2 and this 1, they were replaced by this 3, and then we had a second 3, which we wrote down here. So this multiply is going to be applied to these two values. So we can multiply both of them and then replace them with the result, which in this case is going to be a 9. So you can see that that is our result, and you can see that it is correct. If you know the data structure, or you're familiar with the data structure, a stack, and you've used that in other problems before, I think this problem is pretty simple to figure out that a stack will be useful here, because basically each operator is going to be applied to the previous values, right? But in the case of this 2, the previous values are going to be removed from the stack, right? And then replaced with the new value, which is a 3. So as we read through the input, each value here is going to be added to the stack. Anytime we reach an operator, the previous two values are going to be removed from the stack, and then we're going to do the operation on them. So in this case, 2 plus 1, and then we're going to take the result of that, which is 3, and then push it back onto the stack. And that's kind of what I was getting at when I was doing the drawing explanation. So really quickly, let's actually run through an example with a stack, and to just make this problem a bit more interesting, let's replace this plus operator with actually a subtract and this multiply. with a divide because it's going to be a little bit different with these two operations, because with plus, these two are going to be added, right? 2 plus 1. But when you have subtract, which order are they going to be subtracted? Well, the intuitive one would be 2 minus 1 because that's the order that they appear in. But 1 minus 2 could be possible, right? Well, in this case, if you looked at the second example, I think they clarify that, yes, it's going to be this way, right? 2 minus 1. Let's run through this with a stack very quickly. So we read the first value, it's a 2, we add it to our stack. Second value is a 1, we add it to our stack. Next, we get the subtract operator. What does that mean? That means we pop these values from our stack and then do the operation. So in this case, it was 2 minus 1. That's going to be a 1 over here. Next value is a 3, we add it to the stack. Next, we have a divide operator. So in this case, it's going to be the same order that the values appear in. So 1 divided by 3, we're going to round towards 0. So in this case, it's actually going to be 0, right? So we pop this, and then replace it with a 0. And we're guaranteed, since this is always going to be valid, that we're only going to be left with a single value in our stack. So that's the value we're going to return. So in this case, the answer is 0. So that's pretty much the entire solution. Now we can code it up, but I just want to mention that the overall time complexity is going to be big O of n, because we're just reading through the input string, adding each value to the stack, and removing it at most once each. So, time complexity is 2 times n. In other words, it's big O of n. The memory complexity, since we do have the stack, is also going to be big O of n. So now let's code it up. Let's code it up. Like I said, we're going to need
daily temperature problem. So let's see if it is what kind of problem it is. So it is not a design problem. Okay, so let's do this right. So let's again reset the timer, start the timer. So let's go through the problem again. So daily temperature, given an array of integer temperature represents the daily temperature, return an array answer such that an array I is the number of days you have to wait after ith day to get a warm temperature. If there is a no further day for which it is possible, keep ai answer I equal 0 instead. Okay, so what we do is see if like for the temperature 73, does we have any other day? Okay, return the number the day I takes to get warmer. So for this problem, simply we have 73. We check if there is any number, any day temperature higher than 73. So as there is, so that is 74. Okay, so we have 74. So we have 1 for 74. We have 175. So we have 1 for 71. We have 72, 76, 73. So for 3 days. So we have, where do we have 4? So 75. We have temperature higher. So there is no temperature higher than these. Do you need higher or lower? Given an integer temperature represents the daily temperature, return an array answer such that ai is the number of day you have to wait after ith day to get a warm temperature. From ith day to get a warm temperature. If there is no future day for which this is possible, keep ai answer I equal 0 instead. Okay. So for let's go to the second example. So for 30, we check is there a warm day after this. So 40, 50 and 60. So we have warm day. So we have warm day 1, 2, 3. For 40 we have again 2. So for 50 we have 6. For 60 there is no higher. 5. After 75 we have only 76, 1 day higher, but we have 1, 2, 3, 4, 5 day lower. For 73 we have 72, 69. Once again, I will read through the problem. Let's try to understand. Like, given an array of integers, temperature represents the daily temperatures, return an array answer such that array I is the number of days you have to wait. So array I is the number of days you have to wait after the ith day. Is the number of day you have to wait after the ith day. After the ith day to get a warm temperature. So okay, so how many days you have to wait to get? Okay, so if we have 73, how many days we have to wait to get a higher temperature than 73? So only one day we get 74. So to get a 74, how many days we have to wait to get a higher temperature than 74? That is 75 one day. After getting 75, how many days we have to wait to get a higher temperature? So 1, 2, 3, 4, 4 days. Okay, so simply how many days you have to wait to get higher temperature, not how many temperature are higher after that. So how can we solve this? So we know it's a stack problem. So what we can do, how can we solve this? Let's add this one. So how can we do this? So we'll add the stack, in the stack the first day. Then if we add the second day, if we check the first day, so we know the fourth, so we can be sure for the last day it's 0. Okay, so we can be sure for this day we have 0. For this day, if we check if it's greater than 1, if it is greater, if this day is greater than this day, so again we have 0. So again we check if this day is greater than this day. So no, this day is not greater than this one, so we add 1. So again we move on to this day, we check if these 69 is greater than 72. No, so we add 1. So again we go to this day 71, check 69 is greater than 71 is greater than 69. So no, 71 is greater than 69 s. So what do we do is simply pop this one day, then we again check this, we pop this one. Okay, then we again add back. We move back in the stack to see the day that is greater than this one. So let's copy these. Let's add paint. Let's add this. Okay. So simply what we're going to do is create a stack. We'll, instead of starting from the front, we'll start from the last. So, and we'll have another array as a result. Okay, so what it is, for the first day we know there's 0, so we'll add 73 to the stack. Then what we do is we'll add, then we'll see, then after adding the first, we'll check if the second array, if whatever we are adding, if it is greater than whatever elements are in the stack. Okay, so whatever element are in the stack, not just one element, whatever the element are in the stack, if it is greater than all, we add 0. Even if there is one element smaller than some greater than this one, we'll add that element. Okay, that count. So if for 76 we check if there is any element greater than 76. No, so we'll add 0 and we'll add 76. Then we'll go to the 72, we'll add 7. Before adding 72, we what we do, check if there is any day greater than 72. Okay, in the stack, how many days are greater than 72 in the stack? So there is 1, so we'll add 1, then we'll add 72, then we'll move on to 69. So not how many, at how many days. We'll go to the stack. If we check if the next element in the stack is greater than current element, as it is greater than current element, we just add, we'll have another element as a result. If we check this one, we'll add 1. If we check this one, we'll add it, we'll increase it. So for 69, we'll check all of this. So first we check this one, is it greater than 69? As so just add 1. Okay. Now let's add 71, and result is again 0. So what do we do? Check if for 71, is the this element greater than 71? No. So again we add this element greater than 71. So if it is not greater than 71, we'll add 1 day. Again we'll check if this day is greater than 71, as it is. So what we do is second day. So again we'll add 75 as a 0. So if we check this day is greater than 71, if 75, 74, if 21 is greater than 71, no, so we'll add 1. Again we'll check if 79 is greater than 71, no, we'll add 1. Again we'll check if 75 is greater than 72 is greater than 75, no, so we'll add 1 day. Then again we'll check if 26 is greater than or equal to greater than, if 76 greater than this, greater than or equal to, if it is greater than, okay, as it is greater than, so we'll add again 1 to the result, and we'll add it 4. So if it is smaller than, if it is 73, so we add 1 and 4. Then again we keep on moving. Then for 74 we'll have 75, and for this. So basically what we need to add element in the stack from the reverse order. For the current day temperature, what I will do is see if we'll see in the reverse order, if that day, check it in the reverse order, see if that day temperature, that day and previous day temperature, next day temperature, if it is greater than the current day. So it is not, they will keep on moving down into the stack. So how can we move down into stack? Again we need to, again after moving down, we need to is add back those elements. So look through the elements in the stack. So this is another way, where this is a non-destructive way. Okay. Top pop non-destructive loop using copy. With the stack, if we have a copy of the stack, we loop through the stack. Passed by a value created a copy. So we create a copy. Then third is auxiliary stack, looping by moving to an auxiliary stack. So we know how to solve it. Like we have a basic idea of how to solve it. So let's start by creating stack. Stack of stack of int. So we have stack. Then we have vector of int as a result. That will be same size as start 3. Temperature dot size, whatever the size that is, this will also be the same size. Now we are going to do is loop in reverse. Int n is equal to t. okay, what is temperature dot size, okay. Okay. So while I n minus 1 I plus plus, so while I is greater than or equal to 0, what it is I plus plus, sorry, I minus minus 1. Okay, so now what it is, we have the last element. So basically we can, for the first element, what we need to do is create another function so that we can check. So we can do this non-destructively. We can count how many days we need to move on, get an element greater than this one. Okay, so what we'll do is create another function that will return int move through stack. Okay, so that will be stack of int as element as copy. So we'll have a stack. So what we'll do is simply we'll call simply what we'll do is result I, so last element. What are the that in that? So then move through stack. Okay, so what we're gonna do is pass in temperature, temperatures, and the stack as well. So we need to get temperature to okay. So int okay, temperature. Okay. So I need to get temperatures I this. Then what we do is whatever this element we need to push as that, push temperatures, but I reckon to push it. We need to push that into the stack. So for what it is, we'll have int result. Okay, so it is at see how many days. So it will start with 0. Okay. What we'll do is loop through the stack. So we'll have stack while stack dot empty, while stack is not empty. What we do is simply check if temperature, our temperature is our temperature is greater than stack dot top, what is result plus plus and stack dot below, else just keep it. If our stack, our temperature is greater than stack dot top, we add result plus plus. Okay, once if stack dot top is greater than, so stack temperature is greater than, so if 76 is greater than 73, yes, so what we do is add 1 day. Okay, Start day. Start with 0 day. We have 1 day. We add 1 day. Okay. Then we pop. We have okay. We pop. Then for if we go to 72 or if we go to this 75, we'll add 1 day. If our temperature is greater than at 3 day. Okay. Then for this, when we break, if our temperature is not greater than this, we add break, and then again we day plus plus. So if our temperature is greater than, if temperature, if our stack the top, if top is smaller than equal to, or you can just flip it like this way. If our stack the top is smaller than or equal to, okay, temperature. So if our stack the top 73 is smaller than 79, okay, so we add 1 here. So for this one, for the start for 75, okay, 71 is smaller than 71 is smaller than 71 is smaller than 75, okay, so add 1 day. 76 is smaller than or equal to, so add 1 day. 76 is smaller than, add 1 day. So 1 2 3, then if 76 is smaller than or equal to, no, so we break. So again we add day plus plus. We need to add for this last one, so day plus plus, and then we return die. Okay, so simply return die. So for all the elements we keep on this std test cout. Right. So first we'll add 70. First we'll have nothing. We come here. We'll return 0. Okay. For next element we have 73. For this we pop up. Right. No one. So we have a compiler error. Paste it. Okay, we need to return to you and return result. Okay. So what's the issue? We have just move through step. So we're passing it. Oh, okay. Calculating it and then find the result. So move through step. Heap buffer overflow. Okay, so heap buffer overflow. Pass empty. So this time, if it is not empty, we will simply return 0. Starting from the last element. So what's the issue? Why heap buffer overflow like this? Function like this. So I think this is very good. So what we do, we create it. Whatever the result is, whatever I use that push back instead of push back, we do add element from the questions as possible. So we'll have push. So insert ping 0. So always insert at the 0 location. So place push back. So I have insert. So what do you insert? If you do insert, all of the element have to be moved. So that will be push back. Instead of this being a result, let's do clean. Then we have another method of int as a result. Then we will do is for each I need to data size -1. Sorry, 1 second. It has at least 1 and temperature is 100. Let's equal to 0 minus. Let's equal to this. Let it push back to set what it did work. So for this we are getting 1. If top is smaller than repeat, so it is as it is smaller than 73 is smaller than, it is not empty. So there is an issue here. Okay. Top is smaller than repeat, so we add day 1. So this is added day 1. But even after day 1 there is no situation 0. So this shouldn't add. So what is basically adding 1 here. Okay, so 73 is smaller than our repeated temperature, so we added day 1. So let's wait for day 1, day 2, day 3, day 4, day 5, day 6. If small one, we added it plus. And it is we add the day. Should have greater than, temperature is greater than this, we'll add plus. If we do this, we'll do opposite. Temperature. Temperature if it is greater than, this is greater than stack dot top we add. So this will also give plus as this is greater than this, we add 0, add 1 day. So next station, so this will also give the same, nothing different, we are just changing. We are just changing that. But what you need is while doing this, we create another boolean found day get created found the created by default it will be false. We did add this. Keep on doing this. Click. Created. False. If this never runs, if all it is smaller, if there is sorry, if stop is always smaller, if it never goes, if it never becomes true, if found they created true, if it's never becomes true, all you need to do is if found they created is false, all you need to do is run 0. So let's add another 5 minutes. Okay. So if you do this now, so again we got requirements 4 0 1 2 3. So this 3 0 1 2 3 0 1 2 3 4 1 2 3 4 for 74 it says 3, so 1 2 3. So for this greater than, so that's is, let's flip it as the top is smaller than or equal to, even it is equal to, we need to add 1 day. Okay. Temperature. So we are not is equal to equals to, so 1 day, 2 day, 3 day. So for 74, 1 day, 2 day, 3 day. Okay. Either we can do as the top is less than or equal to, or either temperature, or we can do the previously, like temperature is greater than or even equal to, we need to add 1 day. So this will work now. Okay. This okay, there is a wrong answer. So time exceeded. We are getting time exceeded issue. Okay, for long this problem. Okay, because we are already going through all the time. Keep on going through. So basically our logic is right, but it's taking too much time. So what can we do is boy so we are able to implement it. Okay. In general way. So it's not an optimal solution, as we loop through all the stack again, we pop everything again, we check here, so it's a lot of work. Okay, So, and again we are reversing it through the time exceeded. Again, time exceeded for another. So we keep on getting time exceeded, okay? So there is no way to get. So how can we optimize this specific problem, okay? Can we optimize this specific problem? Can we optimize this problem? Can we optimize this one? Can we? So temperature length can be 0 to 10 to the power 5. This value is between 30 to 100. So let's go through the solution. We know we have to use a stack. How?
Hey everyone, welcome back, and let's write some.
So how we are going to use this stack? We already our solution is working. So if we try to do the same problem outside this LeetCode with the same input, it will take more time, but it will give the correct answer. Okay, but LeetCode has a limitation of certain time the code needs to be run. Okay, so that's why it's giving time exceeded. Okay.
More NeetCode today. So today let's solve a problem, daily temperatures. We are just given an array of integers which represent temperatures. And we want to return an array answer such that at every single position in answer, it's going to be the same exact size as our temperatures array. And at every single position in answer, we want to know for the ith day, whatever the temperature was on the ith day, we want to find how many days did it take for us to find a temperature that was greater than the temperature on the ith day. So for example, let's take a look at this temperatures array. We can see there's 8 values in the temperatures array and there's 8 values in the output for each value in the temperatures array. For example, 73. How many days did it take us in this array to the right of 73, how many days did it take us to find a new temperature that was greater than 73? Well, on the exact next day, we found 74, which is greater than 73, so it took us 1 day. So in the first position, we're going to return a 1. What about 74? How many days did it take us to find a new temperature that was greater than it? 75, 1 day later, right? Okay, for 75, how many days did it take us? 71 is not greater, 69 is not greater, 72 is not greater, but 76 is greater, and you can see that took about 4 days, right? So then we return a 4 in that position. Now there are some temperatures that never had a temperature greater than them. Look at these last two temperatures. We had a
So we can implement it in different way also without using stack. So but the problem said we need to use stack, so we are using this, we are trying to solve this way. Otherwise we can just create a pointer here. For this pointer we keep on checking if there is an element greater than this one. We keep on checking. If we find, we add that day. Again, further we move on to this pointer, we keep on moving, but still that will not be that will not be an optimal solution again.
76, nothing to the right of 76 is greater than it. And of course, the last position, 73, there's no temperatures to the right of it in the first place, so nothing was greater than 73 to the right. So for these ones, we're going to return a default value of 0. So we're going to build an output array. Now, looking at the input, what's the brute force way to do it? Of course, we could do an n squared approach, right? Like for every temperature, we would look through the entire temperature array after it, right? And see, okay, how many days did it take us to find a temperature that was greater than this one, right? And then do the same thing for the next temperature over here. Look through the entire array, see, you know, what's the first day that we could find a greater temperature, and keep doing that. Now, that's going to be big O of n squared time complexity, but there actually is an easier way to do this problem if we use some extra memory. Now let's just iterate through the input array once going to the right, but we do need to know that, for example, we have to remember the previous temperatures that we looked at. So if we, let's say the previous temperature here was a 73, like in the input example, and then the next temperature was a 74. When we get to this position, we have to somehow remember what was the temperature that came before it, right? Now, obviously, we could use a list for that, or in this case, a stack would be more intuitive, because one thing we're going to notice is if we get a temperature greater than it, 74, right, then we're going to say, okay, what was our previous temperature, 73? So this temperature is greater than it, right? So we can keep track of what index this occurred at and what index we're at right now, and say, okay, the difference between these indexes was 1, right? We clearly found a temperature, the first temperature, greater than the 73. So then what are we going to do from our stack? Well, then we don't have to remember this anymore, right? We're going to say, okay, we're going to put a 1 in the output, and we can pop this from our stack, right? So we're going to do stack.pop. So this will be popped from the stack. Now, when we get to a 75, the exact same thing is going to happen, right? Clearly, we see these temperatures are in increasing order. So we see, okay, one day it took us to get a temperature greater than this. We'll put a 1 in the output, pop this from the stack. And if we just had increasing temperatures, that would be really easy for us, right? But it's not always going to happen where we have increasing temperatures. What happens if we had a 72 that came after it? Well, we would look at this 72 and compare it to the top of the stack, say, okay, this is not greater. So we can't pop from the stack, but we're also going to take this value and add it to the stack. So now we're going to have two values inside of our stack. And what happens if we got another smaller value, 71, right? So far, for none of these values do they have a temperature to the right of them that's greater, right? So all three of these are going to be on the stack. What are we noticing about our stack? It's going to be in monotonic decreasing order, right? This is a type of stack problem that I have solved on this channel a couple times, but this is more of a beginner-friendly monotonic decreasing stack problem. What this means is that our stack is going to be in decreasing order. That's what monotonic means. It's always in decreasing order. Now, technically, what happens if we got another 71 over here, right? Well, in that case, 71 is not greater than this, so all four of these would be on our stack currently, right? So it's technically not monotonic decreasing order. It could be equal as well, right? We're noticing it's not strictly decreasing. If two values are equal, they're also going to go on the stack. But if we got a greater value, if I got to a 72, right, what am I going to do? Clearly, 72 is greater than the top of our stack, so I pop this one, right? But now we have a new value on the top of our stack. This one is our 72 greater than this? It's not. So our stack is like this now. We looked at our stack. We took this guy out. This is no longer in our stack, but these three values are in our stack. And still, notice how the stack is still in monotonic decreasing order. It's always going to be the case. What happens if instead of a 72, I had a 73? Then of course we'd still pop this 71, and then we'd also want to pop this 72, because now 73 is greater greater than 72, we pop this. But it's not the case for this one. But if, we change this value to a 74, excuse my bad handwriting over here, but if we change this to a 74, then yes, we are going to pop this one as well. So no matter what we do, our stack is always going to be in monotonic decreasing order. If I add a 70 over here, we're not going to pop anything. It's still in decreasing order. So let's just run through a quick simulation. Let me show you how we can get this output in linear time using a stack. So first value 73, we're going to compare it to the top of our stack. Our stack is empty, so we're not going to do anything. We're just going to take the 73, add it to the stack. Next, we're at 74. We're going to compare it to the top of the stack. 74 is greater than 73, right? What index did 73 occur at? At index 0. What index does 74 occur at index 1? So we take the difference, 1 minus 0. So it took us one position to find a value greater than 73. Is greater. We're at 74. We're going to compare it to the top of the stack. 74 is greater than 73, right? What index did 73 occur at? At index 0. What index does 74 occur at index 1? So we take the difference, 1 minus 0. So it took us one position to find a value greater than 73. So we can pop 73 from our stack, and then 74 is going to be on the top of our stack now. Now, exact same thing is going to happen with 75, right? 75 is greater than this. The difference between the indexes is 1. So we add a 1 to the output for 74, and we pop 74. Now we're at, and we add 75 to the stack. Next, we get 71. 71 is not greater than the top of our stack. So all we do is add it. We don't update the output in either of those positions. Again, we get a smaller value, 69. So we add it to the stack. We can't pop any of these. 69 is not greater than either of these. Next, we get a 72, right? 72 is greater than 69, right? So we pop 69. What was the difference between the indices? It was 1. So we're going to take in the corresponding output position, which is in this position for 69, we're going to say, okay, there was an index difference of 1. Now we're going to look at the next top of our stack, 71, pop 69. What was the difference between the indices? It was 1. So we're going to take in the corresponding output position, which is in this position for 69, we're going to say, okay, there was an index difference of 1. Now we're going to look at the next top of our stack, 71. So the difference between these two is 2. So for 71, we're going to say it took 2 days for us to find a greater temperature than 71. So for this position, we add a 2. So we pop 71 from our stack. Now 72 is not greater than 75. So we still have a hole in our output over here. We never found a greater temperature than 75 yet. And similarly for 72, we have a hole. Next, we get 76 and compare it to the top of our stack. So 76 is greater than 72. We pop 72. The difference, the number of days it took us was just 1 day. So we can add a 1 for 72. And then we look at the next top of our stack. Yes, we finally found a temperature greater than 75. It took us 1, 2, 3, 4 days to do that. So we can add a 4 in the output in the corresponding position. Yes, we finally found a temperature greater than 75. It took us 1, 2, 3, 4 days to do that. So we can add a 4 in the output in the corresponding position over here. And we can pop 75 from our stack. I think I just need one more square over here because we have one last temperature in our input, 73. So we're going to add 73. See, 73 is not greater than 76. So we can't pop that. And now at the end, we have no more temperatures to add, right? We still have 2 temperatures left in our stack. And whatever the default value for the unpopped temperatures is just going to be 0, right? They told us in the description of the problem that if we can't get a greater temperature, we're just going to put 0 for these. So that's how we build the output. You can see it exactly matches the output that they built in the example. And we did that in linear time by using this monotonically decreasing stack in O of n time, O of n memory. So now let's jump into the code. So we are going to have a result. result or answer array, and it's initially going to be default values of 0 because that's kind of what they tell us. And it's going to be the exact same length as the input array temperatures. I'm also going to have a stack. Remember, this is our extra memory. It's going to contain a pair of values. In the drawing example, I only showed that we're adding the temperature, but we're also going to add the index of the temperature so we can calculate the difference, basically calculate the number of days it took us to find a greater temperature. So we're going to be adding two values to this stack, a pair of temperature and the index that that temperature occurred at. Next, we're just going to iterate through the temperatures array. We're going to enumerate this, meaning we're going to get the index of it and the value. Here, int. You can use this type pair. So this is how we can get a pair in this, but how can we read it from? So what we do is start at the top, we get them, get it first, and we get second. Or start at the top at first, start at the top at second. So we can do the same. So pair. So see if still get an error. This is objective. How to get n size n and all initialized to 0. We need to do this vector of size n initialized to 0. Okay, so we instead of doing it like this, we need to do it like this. So now, okay. So now what we'll do is move through which I is equal to 0 while I is less than I. Is okay. We have this one. Let's again start a timer. Start the timer. Start 2 times. Okay. Let's see if I can do it in less than 10 minutes. So after going through the solution explanation. Okay. So we have this one. What we'll do is we'll simply check if temperature.I is greater than s dot top. So that will be nothing. If we do this right now, I think it will give an error. Okay. So what we'll do is stack the top that first. Okay. So if our point, if our temperature is greater than
if our temperature is greater than, we do this. So we are looping through. So what if we check if this is, we need to do decreasing error. So if temperature I, it's not also okay, if it's greater than top element, then we calculate. Then we do what it is result result whatever index we are on, we'll calculate it for that. So I, what it is, what we can do is if current temperature is greater than as the top, so this is greater than as the top. So what is on the top? So we have 73, then 74, so 0 and 1, 73 0, 74 1. So 74, if 74 is greater than 73, what we do is at index 74. So at index 74, that is this at I, what it is simply I minus as the top, that's we here in the second. So if we do this 74, we are adding at 74, so we don't need to add at 74. If 74 is greater than, is the one we have to add it at, that's that top. So what it is, if this temperature is greater than this one, so we need to add at this at 73. So at 73, whatever the 73, whatever the stack element is on the top, at that index, what we'll do is whatever the index minus whatever the index we are trying to add. So that will be at index 0, 1 minus 0, 0. Otherwise, if temperature is not greater than, we keep on adding the element to the stack. Stack that else, it's not else, just stack that push. Yes, it's push. How do we push the element to the stack? So pair, how do we push stackable? So we can push it like this one. So we do this. What do you need to do is we need to push temperature I and I. Push it. Then what it is, if it is greater than, we calculate this, then just that pop, just pop. We keep on calculating till we go to the end. If it is not, we keep on adding, then we will get calculated for that those one. Or if we like for 75, then we go for this one, so we calculate it for this one. So for this, this is on the top of the stack. So for this one we calculate for the then we add 75. Calculating, popping. Then we add. Then we again add these. So I think if we don't do else, that should be fine. Okay. So we add. So for this one, for 75, for this index we add for 75. What it is, add this one, we move on to this one, then we move on to this one, then we move on to this one, keep on adding, and when we reach here, what it is, we calculate it for this one, for the top of the index, calculate it for this one. So 72, we'll add one here, then again we move on to this one, 73, 73, 73, we have added 76, we calculate this, pop this one, add 76, calculate this, nothing, so we never added any of those elements. So instead of doing, we need to want to move through this one, so we are able to do this. Once we reach here, we keep on adding, we reach here, so all of these are still zeros, but we have our stack. So again, we will realize while stack is not empty, what if the stack top, this one to get the stack. So we move from 0 from here to here, we added 1 here, so this will not work simply. So 1 second, so so temperature high, then high. Just okay, now we have some issues. Once we move to this element, we have this, show this to the top, pop. So we popped once. If it is greater than, if it is not greater than, we add. Once we reach, if it is greater than, we do this. So we'll do this till we get, once we get 76, we calculate this one. So again, we need to calculate this one, then we need to calculate this one, then we need to calculate this one. So what I will do is, while once we get the greater temperature, pushing while started, if we have this, we keep adding. If we get a greater temperature, all we do is while started, while stack is not empty, what we keep on doing is keep on calculating this one, popping the elements from the stack. So pop this one. So if you're 75, we add 76, then we add 77.9, so we add 76, so we are at 76. We are at 76, so we do this minus this. So instead of like this. So pop 72. We added at 72, so this one's this. So let's do 75, then we get 71. So we keep on adding to this step of 75, keep on adding. If this is not greater than, we add to this step. If this is not greater than, we add to this step. We add to this step. This is also an error. So we error from 75, then 71, then 69, then 72. We have 75. Once we put 75, we check if 75 is not, we push that, then we put 72, 1. So this is not greater than the top 71. So we put 71, then we put 76. With 76 greater than the top 71 more. We check if 72 is greater than 69. As 72 is greater than top of this stack first, it is 69. So once we put this, this index at 69 index, what are we doing is, let's put the 79 index where here. So we put this one is this, so we get this one. So we pop 72. So we pop 69. Then again pop 69. So we pop our bird and then we pop 69. Then again next situation. So this is not empty. If we do this, so this is also fine. So we get 72. So that's this minus this. Then again we go if where it's not empty. So what we do is 72, that I minus this, so this will give us this, but it will pop 75. So we do not need to pop. So while still first while temperature this so instead of doing empty while so while temperature this is temperature I is greater than 0. So once we go to this 75 is not greater than 72. 75 is not greater than 72 is not greater than 75. When we add 72, we add 76. Go to 76 greater than this. 72 is greater than we add 72 greater than by I. 75. Pop this board. Yeah, this one. See if this works. So there's some kind of error that is like stack is not there's nothing in the stack. So instead of starting at 0, we'll just start at 1. Stack dot push. This is push to various temperatures 0 and 0. Still we are getting stuck. What is the reference binding to this line? 73. So reference binding is line. So what was the defined behavior? Temperature here at the top. that index. Let's not that element. And this is first. And step not empty. And stack is not empty. Yes, if the stack is empty, we use and the stack is empty. If it is equals to, we just add. So, what's the issue? Let's copy this one. Let's put it. Let's exhibit it. So this is almost correct monitoring solution. You have conscious bug left that can crash a program. That is, you are calling as the top before checking if the stack is empty. If the stack became empty after pop, the next loop will crash. Okay. So instead of doing it next, first check this one, then we check this one. Which is the correct way. Okay, so this also matters which you check first. First we check if it is not empty. If it is not empty, then we check. So now, if we started from, let's start it from 0. If we remove this one, will we get the correct answer? Still we will get the correct answer. But still our solution is too slow. Your solution is too slow for this one. It was the top, then I went top. Top. So we are pushing only I, but they are only pushing index to the stack. We are pushing both index as well as pair. So if we do this, what are we checking? Okay, so we are checking if that top elements and this. Okay, so I understand. So if we, instead of doing it like pair, if we do it as int, then what we need to do is, instead of pushing both, we need to push I. Then instead of checking s and s dot first, we do is, we know the index that we are going to check. Okay, so whatever the index, we know the index which is on the top of the stack. So at that index, what temperature we have? So what is temperature we have? So instead of doing that, we get s dot top. So then instead of doing this, we can do s dot top at the top index. I the top stack and pop. Okay, so this is an other alternative approach. So what you do is app is approach 1, save it, and TPP ROCH approach to say. So let's move on to the. So that's it for today. Okay. So tomorrow we'll again start solving these problems from the stack. Then we'll move on to the binary problems. So today we solve these two problems. Okay. So okay. Thank you for watching.